So hello everyone, in this video we discuss about capacitor. First of all, what is capacitor? Capacitor is nothing but a electrical device, electrical device which is used to store energy, and particularly energy is electrostatic energy. Energy. So first of all, we discuss about capacitor of one conductor, which is a spherical capacitor. A spherical capacitor is bad capacitor. We discuss in this video why a spherical capacitor is bad capacitor. So this is a spherical capacitor of charge plus q, and we have to find capacitance of capacitor. Capacitance, which is denoted by C, directly proportional to maximum charge, and capacitor inversely proportional to potential difference. So capacitor equal to q maximum divided by V. This is the formula of capacitance. Capacitance of capacitor. Now we know more about capacitor and capacitance. Capacitance is a scalar quantity. Unit coulomb, COMB, coulomb by volt. Now we can also write capacitance C equal to Q divided by V can be replaced. Q divided by V can be replaced by Q divided by R. This got this, and C equal to R by K. R divided by K can be replaced by 1 into 4 pi epsilon naught. So C equal to 4 pi epsilon naught R for a spherical capacitance. Now capacitor of two conductor. Combination of two conductor having equal and opposite charge. Opposite charge. This is the picture of the capacitor. This is plus Q, this is minus Q. And electric field arises from plus Q and in that minus Q. From here to here. This is electric field. And outside the capacitor, electric field is 0. Now, formula of capacitance of capacitor C equal to Q by delta V for capacitor of two conductor. So C equal to Q by V1 minus V2. Now here we have question why a spherical capacitor is bad capacitor. Solution is that a spherical capacitor has plus Q charge on its surface. So electric field arises from surface to the infinity and store energy from surface of a spherical capacitor to infinity, which is useless. So a spherical capacitor is bad capacitor. Now we discuss about parallel plate capacitor, conducting plate. This is the picture of the concept. This is the parallel plate capacitor. The first plate has charge plus Q and the second plate has charge minus Q. The area of both plate has A and the distance between the plate is D. So we have to find the capacitance of parallel plate capacitor. For this we have to find delta V, and for delta V we have to find electric field. So E net equal to, as we know, electric field arises from positive charge and terminate as negative charge. So electric field arises from positive charge, which is E1, and another electric field which terminate at negative charge, which is E2. So E net between the parallel plate capacitor is E1 plus E2. So E1 equal to Q divided by 2A epsilon naught, as we discussed in first chapter. Electric field due to conducting plate equal to Q divided by 2A epsilon naught plus Q divided by 2A epsilon naught equal to Q divided by A epsilon naught. So E net equal to sigma divided by epsilon naught. Sigma is the Q divided by A. Sigma is Q divided by A. So E net is sigma divided by epsilon naught between the parallel plate capacitor. Now delta V is E into D. Delta V equal to E is Q divided by A epsilon naught into D. So capacitance equal to Q divided by delta V. We discussed previous. So we can also write C, which is capacitance of parallel plate capacitor equal to Q divided by delta V is Q divided by A epsilon naught into D. This cut this and capacitance equal to epsilon naught A divided by D. So this is the capacitance of parallel plate capacitor. Now C equal to epsilon naught A by D. So capacitance directly proportional to area of a plate, conducting plate. C inversely proportional to distance between the plate, and C directly proportional to the epsilon naught. So the graph of first equation is C versus area is this, and the graph of second equation C versus distance is this. Now capacitor with dielectric means in other medium except air. What is the capacitance of capacitor with dielectric? So this is the picture of concept. This is dielectric. So we have to find the capacitance between the parallel plate capacitor in other medium of dielectric constant K. So for this we have to find delta V, and for delta V we have to find electric field. So E equal to Q divided by A epsilon naught in air, but this is other medium of dielectric constant K. So E equal to Q divided by A epsilon N equal to Q divided by A epsilon naught epsilon R, which is equal to Q divided by A epsilon naught. We can write epsilon R as K. So E equal to, we can also write this E1 to distinguish between E and E1. E1 equal to E by K. This is first equation, and delta V equal to E into D. So delta V equal to E1 into D. So delta V equal to E by K into D. Here we get delta V equal to ED by K. So capacitance C equal to Q divided by delta V equal to Q divided by delta V is ED into K, which is equal to Q divided by V. E can be replaced by Q divided by A epsilon naught into D. This cut this and also K. So C1 equal to epsilon naught A by D into K. So C1 equal to, this is the capacitance of parallel plate capacitor in air. So C naught into K. So this is the capacitance of capacitor, parallel plate capacitor, which is present in medium of dielectric constant K, equal to C naught is the capacitance of capacitor in air into K is the dielectric constant. Now, force on one capacitor plate due to other plate. This is the picture of the concept has two parallel plate capacitor. One first plate has plus Q charge and the second plate has negative Q charge of area A and distance between the plate is D. So we have to find force on one plate equal to Q E. Q is the charge of one plate and E is the electric field due to one plate due to one other plate, second plate. So Q is charge is Q and electric field due to conducting plate is Q divided by 2A epsilon naught due to one plate. So force equal to Q square divided by 2A epsilon naught and pressure equal to force per unit area. Pressure equal to force is Q square divided by 2A epsilon naught and area is A. So Q square divided by 2A square epsilon naught, and we can also write this is Q square divided by A square can be write as sigma square divided by 2 epsilon naught. So pressure equal to sigma square divided by 2 epsilon naught is the formula. Now electrostatic energy per unit volume, which is represented by U equal to energy per unit volume, nothing but sigma square divided by 2 epsilon naught. We can understood this concept by the dimension of pressure and volume energy density. The dimension of pressure is equal to ml minus 1 t ke power minus 1, and the dimension of electrostatic energy per unit volume is also same. U equal to energy per unit volume and the dimension of U equal to m L minus 1 T minus 2. So by this concept we can understood that the formula of pressure and electrostatic energy per unit volume is same. So then what is the energy present between the parallel plate capacitor, which is represented by E equal to sigma square divided by 2 epsilon naught into volume. So sigma square divided by 2 epsilon naught, volume is area into d distance. Why area into d distance is the volume? As we have to find energy between the parallel plate capacitor. Here, what is the energy present between the parallel plate capacitor? So volume is area is a into distance d. The volume is this. So E equal to, you can also write sigma as q divided by a ka whole square into a into d divided by 2 epsilon naught. So q square divided by a square into a into d divided by 2 epsilon naught. This cut this and q square into d divided by 2a epsilon naught. E equal to q square into d divided by 2a epsilon naught. E equal to q square divided by 2, and this can be written as epsilon naught by d is c. So E equal to q square divided by 2c. It is the energy between the parallel plate capacitor of capacitance C. Now E equal to q square divided by 2c. We also know that C equal to q by v. So q equal to cv. So we can write E equal to q can be replaced as cv. cv square divided by 2c. E equal to c square v square divided by 2c. This cut this and E equal to half cv square. So this is the another formula of energy between the parallel plate capacitor of capacitance C.